Hello, fellow chemists. In this video, we're going to take a look at molar mass. This is labeled as an intermediate level video because it assumes you have a basic understanding of the mole and Avogadro's number. If you need a review of those topics, I'll put a link in the upper right-hand corner. So, molar mass, what this is doing, now that we understand the term Avogadro's number, we want to retake a look at what atomic masses are and how molar mass is related to them. So if we take a look at just carbon here, whose atomic mass is 12.01, and we've learned before that atomic mass means atomic mass units. We're just adding up how many protons and neutrons there are in an atom. And it's as AMU. But really what chemists use this atomic mass as is they don't use it with the units of AMU. They use it with the units of grams per mole. And what that means is that if I had 12.01 grams of carbon, I would have exactly 1 mole of carbon atoms, or 6.022 times 10 to the 23rd carbon atoms. If you took a look at hydrogen, hydrogen is 1.008 atomic mass units. That means it's 1.008 grams per mole, which means if you had 1.008 grams of hydrogen, you would have 6.022 times 10 to the 23rd hydrogen atoms. And this is very important because now that we can use this grams per mole term for atomic mass, that's what really allows us to begin measuring out different amounts of elements and accurately reacting them with other amounts of elements to form products. So anytime you have a number that has 2 units on it, like this 12.01 grams per mole, it can be used to convert back and forth between grams and moles. And eventually that's what we're going to use these atomic masses for. Now, it will never tell you on the periodic table that these decimal numbers at the bottom of the elements are in the units of grams per mole. That is just something that you have to remember. Because it is very useful to understand that these atomic masses are actually conversion factors that let you convert back and forth between grams of an atom and moles of an atom. Well, that works great if we're taking a look at individual atoms, but what if you're talking about molecules or groups of atoms? Like, let's say you're talking about an oxygen molecule. Now, an oxygen atom would just be an individual oxygen, but an oxygen molecule is 2 oxygens linked together. Well, if there is no oxygen molecule shown on the periodic table, so what you would have to do is you have to add up the atomic masses of each oxygen atom, and then that would give you what's called the molecular mass or formula mass. And you can use this molecular mass or formula mass to do calculations for reactions that the oxygen molecule will take place in. So how would we do that? Well, if we take a look on the periodic table, oxygen's atomic mass is 15.999. So we're going to just round that up to 16. So you would say you have an oxygen and its atomic mass is 16 grams per mole. And for an oxygen molecule, you're going to have 2 oxygen atoms. So 16 times 2 is going to give us 32 grams per mole. So an oxygen molecule has a molecular mass or formula mass of 32 grams per mole. We call it an atomic mass if it's for an individual atom, and we call it either a molecular mass or a formula mass if it's for a molecule. And you get the formula mass or molecular mass by just adding all the individual parts of the molecule together, their individual atomic masses together. So let's take a look at a few more examples of calculating formula masses or molecular masses from the individual atomic masses on the periodic table. If we take a look at CH4, which is methane, and methane is commonly used as a heating gas. It actually is odorless, but at 5% in the air, it can actually explode. So, scientists actually added H2S, hydrogen sulfide, tiny amounts of hydrogen sulfide to methane gas, and that's what gives it kind of the rotten egg smell. So if you ever have a gas burner and you turn on the gas burner and you kind of have a little eggy smell, that's because it's methane gas. Methane gas doesn't smell like anything. But so that you don't have an accident and fill your house up with the methane gas and blow it up, they put a tiny amount of H2S in it. And that H2S smells like rotten egg, smells real bad. So that's how methane has its kind of the protective odor to prevent it from building up too much in the air. So if we wanted to figure out what is the formula mass or molecular mass for methane, CH4, what you would do is you take a look, okay, what is carbon? Okay, well, the mass for carbon is 12.01 grams per mole. And there's only one carbon in this molecule, so that means we have a total of 12.01 grams per mole from the carbon. And then the atomic mass for hydrogen is 1.01 grams per mole. And there's 4 hydrogens in the molecule, so that's going to give us a total of 4.04 grams per mole from the hydrogen. Then you just add them all together, and that comes out with 16.05 grams per mole. And that is the formula mass or molecular mass for methane. See how we just added the individual atomic masses together. If we take a look at one last example, we'll take a look at laughing gas. So let's say you need to go to the dentist and you're very nervous, and like my wife is, and you want to actually get some medication before you go under the knife for getting maybe a root canal or something. That is nitrous oxide, and that is N2O. So this is nitrous oxide. That's also known as laughing gas. Well, if we were asked to find, well, what is the formula mass or molecular mass of nitrous oxide? Well, what you would do is you would say, okay, well, what's the atomic mass of nitrogen? 14.00. So nitrogen is 14.00 grams per mole. And there's 2 nitrogens in this molecule, so that would be 28.00 grams per mole contributed by the nitrogen. And then oxygen is 15.999, and we're going to round that to 16.0 grams per mole. And there's 1 oxygen in the molecule, so 16.0 will be the contribution from the oxygen. And then if you add 28 plus 16, you get 44 grams per mole, and that would be the formula mass or the molecular mass for nitrous oxide or laughing gas. So now you know that by just looking on the periodic table, you can determine the atomic masses in grams per mole or the formula masses in grams per mole for molecules for any element or molecule where you would need to convert it from grams into moles or moles into grams. All right, that's it for this video. I hope you learned something, and I'll see you for the next lesson.